Hi and welcome to this third video of our IoT and embedded cybersecurity tutorials. So in this video, I'll be showing you how to develop your firmware for your IoT-based temperature and humidity monitoring and control system using the Raspberry Pi Pico-W, a DHT11 sensor, the OLED relay, and the passive buzzer. So the firmware basically will read temperature and humidity from a DHT11, display the values on the OLED, control a relay based on temperature threshold, and trigger a passive buzzer alarm when temperature exceeds a set limit. And later on, we would implement the IoT aspect. So for your firmware design, first you need to create a new file and upload the dependency file into Pico-W. Bear in mind the OLED 0.96 inches requires a library, and the library name is ssd1306.py. okay, so to get this library you need to click on this link, go to my GitHub link. Okay, so once you click on that link, it opens up this ssd1306.py. So what you need to do is you need to come to this point and copy raw file. Click on copy raw file. Then we're going to into our Thonny IDE. So you open your Thonny IDE if you have installed it. If not, please refer to our last video. Okay, so now that we have our Thonny IDE open, the first thing we need to do is to connect our hardware device, which we assembled in our last video. So connect your system. Okay, so click on the stop button to connect your Thonny IDE with the Pico-2 microcontroller. Alright, so it has established connection. So as you can see, the Raspberry Pi Pico folder is empty. If you cannot view this panel, go to view and click on make sure your files is ticked. If you want to see your Raspberry Pi Pico directory or your desktop directory or your Windows directory, so go to files. If I click, you can see. So maybe by default when you open your Thonny IDE, this is what you see. But if you want to see your directories, you go to file and click on view and make sure you tick the files. Alright, so you can see, so our Raspberry Pi Pico is currently empty. So next thing is you are going to create a new file. So our step 1 says create a new file. So create a new file and we save it, Ctrl S. So you're going to save it into your Raspberry Pi Pico, okay, as ssd1306.py, ssd1306.py, and you click OK. Now you copy the codes. So go back, copy the codes from your ssd1306.py from the GitHub link, and you paste it, Ctrl V, and save it, Ctrl S. So now we've saved our ssd1306.py. So this is a library that will be used in this project. The next thing is we create a new file, new, and we can save it as IoT, Ctrl save. Again, save it on your Raspberry Pi Pico as IoT underscore device, device.py. So you save it as this name first. Later on I'll show you how to convert it into a deployment mode. Currently we are saving it as IoT underscore device.py because we are in our development mode. So I'll click OK. Alright, so now we go back to our slides. So we've done the step 1, we've created a new file and we've uploaded the dependency file ssd1306 into it. Then in our new file which we have created, that is the IoT underscore device, we're going to import the libraries we need into our firmware we are developing. So first we need the pin module. We need the I2C. So the pin module helps us control all the GPIO pins on our microcontroller. The I2C module helps us to communicate with our OLED because we are using the I2C protocol. And the PWM, which is pulse width modulation, helps us to generate our sound on our passive buzzer. Then we need to import time. So time helps us to create some delays in the firmware. And the DHT file, we need to import that because we need to control the DHT11. And of course, we are importing this file SSD1306, which we have saved onto the Raspberry Pi Pico. So I'm going to copy all of this quickly. So I'll copy it, Ctrl C, and paste into the Thonny IDE. Right. So first you can create a comment here. So import libraries. Okay. So I'll put it as step 1. So it guides us when we're developing our firmware. Step 1. Okay, import libraries. Okay. Now, having done that, let's go back to our slides. So next slide, which is step 3. It says initialize the hardware interfaces. Alright, so now that we have imported the libraries, we need to initialize all the hardware interfaces, that is the OLED, DH11, the relay. So what I would do is I will copy all of these codes and I would put into the Thonny IDE. So this is the step 2 on the firmware design. So we initialize the hardware interfaces. Okay, so first is the OLED, which is an I2C communication device. So you need to type in these 2 lines of code. So what this line represents is that you are using GP0 as our SDA, I2C0, which has the SCL on GP1, and it has the SDA on GP0. Okay, so this is the default frequency for the OLED device. Next is you need to set the number of pixel of the pixel. So we have 128 by 64, meaning the x-axis has 128 pixel and the y-axis has the 64 pixel. So once you've done this, the next is the DHT11. So the DHT11 is connected to GP2, remember, on our pin mapping. And